guys, we're going to be reviewing and going over how to solve quadratic equations by factoring, but we need to know how to factor. So we're going to go over a couple of concepts called the sum of squares and the difference of squares. All right? So here's some basic quadratic equations that deal with the sum of squares. And there's a pattern that everybody needs to know how to do. Doing positives and negatives. All right, so if we wanted to multiply these two binomials together, all you have to do is understand that you are going to have an x squared. We're not going to do the FOIL method right now. Okay? What's 1 plus 1? We get 2. 1 times 1? Nope. 1. So the sum of these two numbers is going to give you the middle term. The product is going to give you the last term. Okay? What about this one? We have an x squared plus 4x plus 4. Because 2 plus 2 is 4, and 2 times 2 is 4. Go ahead, next one, Maddie.
6x plus 9.
6x plus 9. 3 plus 3 is 6. 3 times 3 is 9. There's the pattern. Okay? Now over here, we use the exact same pattern for the sum of squares, but we're just dealing with negatives. So this one's going to be x squared minus 2x plus 1. Because a negative plus a negative keeps it, that's a negative 2, but a negative times a negative gets us that positive 1. Next one, you'll see the same pattern. It'll be a negative 4x, but it'll end up being a positive 4. And last but not least, we have x squared. There we go. All right? So the pattern that I want you guys to recognize, in order to get these multiplied perfectly, you don't have to use the FOIL method. There's a quick little pattern. Take those numbers and add them together, get the middle term, multiply them together, get the last term. Now we're going to talk about the difference of squares. So what I'd like you guys to do is I want you guys to write x squared minus 1. I want you to write x squared minus 4. X squared minus 9. X squared minus 16. Okay? And we're going to learn how the factoring process happens with the difference of squares. Now, 1, 4, 9, and 16. Those are all perfect squares because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. This right here will factor to x plus 1 and x minus 1. This one will factor to x plus 2 and x minus 2. This will be x plus 3, x minus 3, and last but not least, what do you guys, Andrew, what do you think this is going to factor to? X minus 4. Now, by the way, you guys notice how there's no middle term, there's 0 x's in the middle all the way through? All the way down, there's no x's in the middle. What is negative 1 and a positive 1 added together? 0. What is 2 and a negative 2 added together? 0. So notice, all of these numbers when added together equal 0, but when multiplied together, what do they equal? They equal the final number at the end. 1 and negative 1 becomes a negative 1. So right now, this is your concept of a difference of squares. If you see this, I want to make sure you understand how to factor. So right now, I'm going to give you guys 2 that you guys are going to do in your journal and see if you guys can come up with the correct answers. Here we go. Right now, I'm going to say c squared plus 10c plus 25. I want you to factor that. And over here, I'm going to say b squared. I can write it correctly. My goodness gracious, this board. b squared minus 81. So I want you guys to factor this one. I want you to factor this one. All right, if you guys didn't see the pattern, this is an example of a sum of squares. Okay, what two numbers add up to 10 and multiply together to equal a 25? 5. So we'd say C plus 5 and C plus 5, because 5 plus 5 is 10, and 5 times 5 is 25. Over here, though, this is a difference of squares. We're going to say B plus a number and B minus a number. 81 is a perfect square, because the square root of 81 is 9. No, we're just pretend like we didn't hear that.
Okay.
So 9 plus a negative 9 is 0. See, there's no b's in the middle? But 9 times negative 9 is a negative 81. These would be the factors. These are the factors. Okay? Just like right here, these would be considered the factors of this product. These are the factors of this product. Okay? Now we're going to go and start our assignment. We're going to look at problem number 1. All right? So let's look at problem number 1. And what I'd like you to do in problem number 1, I'd like you to do a quick little drawing so you guys understand what it's asking you to do. We are saying that the number 7 is a root and the number 2 is also a root. So I'm going to do a quick little drawing of what could possibly be the scenario here. We have, oh, that's a horrible y-axis. There we go. What we're saying is there is a root right over here at a 2. And then we also have a root 3, 4, 5, 6, 7. There's another root right here located at a 7. So there's a root at a 2, and there's a root or a solution or an x-intercept or a 0 at a 7. Now there's two ways a parabola could go through this. You could have a parabola go down through the 2, and it bottoms out, eventually goes back up. That could be one of your parabolas. Okay? You could also have a parabola that goes up through the 2 and maxes out and then goes back down. So there's an infinite number of parabolas that can have roots of 2 and 7. We're going to show you a little process of how to solve and make a quadratic equation that goes through those 2 points. Okay? So here's what you're going to do. I want you guys to label this root as letter P and this root as letter Q. So call this P, call this Q. We're going to find out piece of Q. So right now, everybody, this is what I want you to do. In your journal, write X minus P, parentheses. X minus Q, close parentheses, and set that equal to 0. I want you to understand this right here is a root. This right here is a root that you're plugging in. Okay? So, if we wanted to build our quadratic equation that goes with these 2 roots, we want to write the equation. We are setting the equation equal to 0, and we're going to say x minus, what was our value for P? 7. And x minus, what's our value for Q? 2. This is your quadratic equation. But you know what we can do? We can multiply these together really, really, really fast. We're going to have an x squared. What's the sum of negative 7 and negative 2? Sum.
5.
Nope.
Negative 5.
Nope.
Negative 2.
By the way, that's right. If you spend $7 and you spend $2 more, you're uh-oh.
$9 in debt.
Yep. So put minus 9x. What's the product of those 2 numbers? 14. Put plus 14 equals 0. This is your answer, everybody, to number 1. That is the quadratic equation that passes through those two roots.
So we're only coming up with the equation?
That's right, for the first view. For the first view, we're just coming up with the equation. All right? Let's do one more. Let's go all the way over here to number 3 that has a negative and a positive. So you guys can go and do this in your journal, and we can just transfer the answer over. So here we go. I'm going to label this one P. I'm going to label that one Q. I'm going to say, so we're doing number 3. X minus P and X minus Q. This one's a little bit trickier. If I say X minus a negative 5, that's going to become a positive 5. Very good. And X minus 8 is just X minus 8. And we're going to set this equal to what? Set it equal to a 0. Now, how do we come up with our equation again? All we have to do, we're leading out with an x squared. What are we going to do with the 5 and the negative 8? Add them together and get negative 3. Then we're going to multiply them together and get nope, negative 40. Okay. Hey. So here we go. Right here, this is your equation. This is your equation for your quadratic work that has roots at where? Negative 5 and positive 8. Now we're going to do one that deals with fractions. Okay, so the last one we're going to do on this video, we're going to do one with a fraction. We're going to go down here. I don't want number 6. Ooh, number 5. Let's do number 5 in your journal. Okay. Label this P. Label that Q. There's our p-value, there's our q-value, these are two roots. We're going to build our equation. We're going to say x minus 1/3 and x minus 2. That's how you start it out, right there. X minus 1/3 and x minus 2. Now, don't get intimidated. We're just working with fractions. It's not that big of a deal. We're going to start out with an x squared. Now, if you have a negative 1/3, everybody, all right, and you end up just adding a negative 2, that's just negative 2 1/3. But I want us to change this to an improper fraction. So 2 times 3 is 6. 1 more is 7. So change that to negative 7/3. So what you guys write? Negative 7/3 x. All right, this is one of those things where my daughter's been doing this in the 6th grade. All right, changing things from a mixed numeral to an improper fraction. Not quadratic. Not quadratic. All right, then she's also learning how to multiply fractions together, right? No problem at all. Negative 1/3 times negative 2/1 becomes a positive 2/3. Now, technically, everybody, this is a correct answer. This equation right here would have two roots. You would have one root at a third, and you'd have one root at a positive 2. What I'd like us to do is I'd like us to take everything so we don't have to worry about fractions. I want you to multiply every number by a 3. Whatever number is in the denominator, just multiply everything by that number right there, and look what happens. We have 3 times x squared, which is 3x squared. 3 times a negative 7 is negative 21. Divided by 3 is negative 7. And 3 times a 2 is a 6. 6 divided by 3 is 2.
Oh, so you just multiply everything by the denominator.
That's right. Whatever number is in the denominator, just multiply everything by that number, and that will get rid of all of your fractions. Okay? So like I said, technically, that equation right there would give you the same roots, but so would this equation, right?